All right, number one on the review is asking for a few different Lewis structures. I'll draw them out for you here. So 1A is asking us to draw SO4, the -2 ion. Adding up my total electrons, sulfur is in the 6th column, counting from left to right, skipping the center D block. 6th column, plus we have oxygen, 4 oxygens, and they are also in the 6th column. And then simply because of the -2, it's overall negatively charged. That means we have extra electrons. We're going to add 2. So when I add all of this up, we get 32 electrons. Sulfur is going to be my central atom since I don't have a carbon and I only have 1 sulfur. I put the oxygens around it. Using up my 32 electrons, I'm going to start with single bonds. 2, 4, 6, 8. And I'll keep going with lone pairs until I've used all 32. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I have the right number in my picture, but then I have to make sure everyone's happy, everyone has a complete octet. Sulfur and oxygen, neither of those are exceptions, so they do each want 8. Checking each of those elements, this oxygen thinks it has 8 electrons because of the 3 lone pairs and the 2 in that bond. You could say the same for this oxygen, also has 8. This oxygen, my circle's not really centered well, but boom, there, that oxygen has 8. This oxygen also has 8. And then looking at the sulfur, looking at the sulfur, all of those bonds that the oxygen counted, the sulfur also counts 2, 4, 6, 8. So everyone's happy there. Now, I don't need those circles in my final picture. That was just making sure all of the octets were satisfied. But since it is an ion, my final answer needs to have brackets around it and a -2 charge. Going on to B. We are looking at BE, F2, counting up our total electrons. Beryllium is in the 2nd column, so it has 2 valence electrons. Then we have 2 fluorines. They're in the 7th, the 2nd to last column. So they have 7 valence electrons each. That would give us 16 electrons for our picture. Beryllium will be in the center because we don't have a carbon, and because we only have 1 beryllium. We'll attach the fluorines to it. 2, 4, now I'll use lone pairs, 6, 8, 10, 12, 14, 16. You might notice I went in a different order, like I did some on each fluorine back and forth, and I didn't do that in the last problem. It doesn't matter where you start as long as you're willing to erase and move things around as needed. I've used up all 16, so I need to start checking if right away you're like, ooh, beryllium's not happy. It has not satisfied its octet. You're right, the beryllium only has 4 electrons. However, beryllium's one of our exceptions. It's happy with 4 electrons. So beryllium's happy. If you check each of the fluorines, they also have 8 electrons. So we are good. That one's done. And for number 1C, SF2, sulfur's in the 6th column, 2 fluorines that are each in the 7th column, 14 plus 6, so that we are going, oh, hello, have 20 electrons. Sulfur will be in the center. We don't have a carbon to put in the center, and we only have 1 sulfur. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 electrons. Checking, every octet is satisfied. Everyone is happy. Everyone has 8. So that would be my answer for SF2.